So, hi everyone. I'm sorry that this came in that late. I'm actually still in Sweden and it has been hectic today due to the travel schedule. I hope that this video comes out to be better than the previous one, less boring, so that the people who I think died last time live this time. I just want to note before we start that, as we said, this week there was no lecture. There was no physical lecture today, Tuesday, and we will meet on Thursday. Uh, I don't know. I will write it again. I wrote it in a couple of emails. I'm still getting the same question from multiple people. I think if it's not clear still, please approach me on Thursday, and let us talk about it like in person because that might be better. So today's class we are going to cover the process abstraction in more details and some of the process APIs, basically some of the system calls that are available. We sort of touched upon that during the last lecture, but this lecture will actually cover quite a bit on this topic. And this is, if we are looking at reading, this is chapter 4 and chapter 5 in the book. And if you, as I said, I add information that I think is valuable for you guys from some other books. So we talked about one of the main reasons we have an operating system is to provide some illusion of having a virtualized system with multiple CPUs. So nobody really feels that there's just one single CPU. There are multiple CPUs all working together. And these CPUs can be used by multiple applications, and the applications do not really need to think where they are running, or how much CPU cycles they are using, or how much memory they're getting allocated, and these kinds of things. So basically, I mean, this is we sort of covered a bit about of this last time. The way that CPUs are virtualized is by time sharing, by basically having programs run for a certain time on the CPU before they are evicted, and by eviction they can be basically kicked out from the CPU until they can run again, or they can finish whatever they were doing. We will talk about this a bit more in a bit more details in a few minutes. So there's the process abstraction that we also talked about a bit last time, where you basically have an instance of a running program and you consider this a process. And consider this just like the English term process. If you talk about a process, you talk about a procedure, something that you do basically in some sequence. So a process is basically an instance of a running program, and it has some inputs, some outputs, and some resources that it uses. A process basically uses your machine, the computer, and different processes, different applications will have different requirements to run. For example, some processes would be reading a lot of memory, others will be reading a lot of persistent storage, and so on. The operating system, in providing the process abstraction, because this is what the operating system does, it actually gives each process whatever it needs. And to give the process, for example, memory or storage or CPU, it needs to store some information about the running process. For example, memory. How much memory does this process have? And the amount of memory allocated to the process by the operating system will be basically a function of how much data this process operates on, the number of instructions this process have, and basically the variables that change during the actual computations. And this memory is called the address space of the process. So every process running on your computer, every program running on your computer has an address space allocated to it by the operating system. And the process also uses some persistent storage. For example, it reads files from disk. So if your process, for example, is Microsoft Word, then you read a file from disk, you write to the disk when you save, and while you're actually reading the file, you do not read directly from disk because disk access, as we said last time, is very slow. So you actually read it into memory, you preload it into memory, you prefetch the data that you need into memory, and from there you basically start writing into memory and reading into memory. And since each process has basically instructions, the process does this instruction first, so it loads a file first, it reads the file after loading, it selects the first 10 lines in that file, and it operates on each line, changing a letter from capital to small or something along these lines. This is a process. I just described a program. For the computer itself, this is not just the things that I have said. This can be lots of computation. Each one of them can require actually multiple machine instructions to run. And to basically go through this program that I just described, you would basically need something that points to where you are. There is actually a very long answer that we're going to discuss next Thursday on what the program counter does and what the program, the PC select does. But in general, I mean, the PC sort of tells you where you are in the program so that you know where you will go next in the program. You also need a stack pointer. You need also to know where you are in memory. You need to know where you are in the heap. I mean, you need to know where you are in different parts of the memory. So this is yet another piece of information that the operating system stores for a process.